you could write this as log AU plus log AB. And the point of this is, in order to solve equations and simplify things, we have to know these properties sometimes in order to do that. And so that's why we spend a day doing this before we talk about solving equations, which is the next step with logarithms. So addition means multiplication of logarithms. If you have division, and really important, I saw some people yesterday as they were doing it, they were wanting to say like log of u divided by log of v. It's only one log, right? And then you're dividing the numbers. So then you can rewrite that as log of a of u minus log a of v. Well, who was so smart to use u's and v's because they look alike. And then if you have an exponent, power to power, you can bring that out front, which is really going to help us when we solve equations, and maybe you remember that from last year. And if you haven't already started filling in your LNs, same properties, right? And if you don't feel like you can write them all, obviously you don't have to. But these are your go-to properties, and pretty much today we're just going to practice putting things together, breaking things apart. And so, let's see, maybe you guys can work on it a little bit instead of me just standing up here doing it all. I don't know. So I'm going to say plus ln of v, ln of u minus ln of v, and n times ln of u. I like ln so much better than logs. I don't know why. It's just so much easier to write. All right, those are your go-to formulas. You got to know those. Hopefully, by doing this, you'll remember those as we do that. Remember, if you're going on a field trip tomorrow, and we have a worksheet tomorrow, and the same kind of stuff, there'll be graphing on the worksheet, exponential stuff on the worksheet, and then these logarithm properties on the worksheet. And I have that here, so just make sure you get it from me before you leave today. All right, so I just have 3 examples here, and maybe I'm going to let you work 1 and 2, and then if you get to 3, you can, and we'll talk about them. But expand each logarithm. That means break it up using these properties. So when you see division, I want you to know you can break it up as subtraction. When you see multiplication, that you can break it up as addition, and then it gets a little crazy on number 3. But take a couple minutes, and feel free to talk to each other about it if you want, if you get stuck on it. But see if you can get at least 1 and 2 done, and we'll talk about them to see if you remember how to do this. Do you remember doing this also? Anything nice? The 6th hour, they told me, Mr. Alspaw, like, use graphic calculators on this whole chapter. Is that what you're saying? Or they're just trying to make me let you use it? So can you do anything with that? And so as you're simplifying 1 and 2, the idea would be, can you simplify it more, right? Like, once you break it up, are you able to do anything else? Like this. Can you simplify that? No, you do that just for 1 minute. Can you simplify this? Right? So, like, can you simplify that anymore? Definition 1. What's that saying? What's that asking? Not with your calculator. Can you simplify it without your calculator? Right? Can you simplify that? Can you simplify that anymore? So when you pull that x out front, like if you put that back together, wouldn't that say ln of x to the x? Yeah. That's not what you have up here, right? So where should that x go? Which one is it power to? It should be right? Putting it back in top. Okay, so what can you do with multiplication? So, right, that's multiplication. Yeah, but well, it's just x times e to the x, which means this is actually like 2 properties together, because it has a power 1 and multiplication. Step 1 would be, treat this as like 2 and this is like x. So, we simplify that anymore? Do you know what you want to do? Would you simplify it anymore? Do you know what you want to do? Can you go over that? Right? Like that. Can you simplify that anymore? Do you know what you want to do? I see that. Like why subtract? Like why? I see that. All right. All right. Let's see if we. Division means subtraction. Multiplication means addition. Right? So that's the basic property. And then you have to look further. Why would I want to break them up? Maybe I can simplify it a little bit more now. Over here, log 3 of x, we can't do anything with that. But log 3 of 9, we can simplify, because that's just saying 3 to the what power equals 9. So what does that equal? What's log 3 of 9? 2, and it would be minus 2. This is when parentheses really matter. We just took a calculus test, I don't even know, Monday, and there were a few people that missed probably 4 or 5 points on the test due to parenthesis issues, and it seems like a simple thing, but it really matters, right? Log 3x minus 2 without parentheses means log 3 of x, and then you subtract 2. Putting parentheses around it means it's the whole thing is taken to log base 3, and so just make sure you're kind of aware of grouping symbols as you're doing these. This one, a few people have x in the wrong spot here. That x is to the e power, so you can't bring it in front of ln, but you could bring it to the front of that using that power to a power property. And then remember, the great thing about ln and e is their inverses. And what does the ln of e equal? Which means the better answer on this one is ln of x plus x. And again, you can't add those two x's together, right? It's ln of x, and then you add x. And so no parentheses needed, but just make sure you know you can't put those together. Questions about those two? Always be aware, like, can I simplify it more? That's kind of the trick that kind of happens. So then I gave you number 3, that's really making you think a lot more about these properties. I would do it in a couple steps. Step 1, just like number 1, I would do the division. So I would say log 5, and some people are really good at doing this all at once, and that's great, but I'm going to show you a few steps here. Minus log 5, and I'm going to say x squared minus 1 in parentheses, because again, if you don't put it in parentheses, then it's read as x squared and then minus 1. Oh, thanks. What else could I do to simplify that problem more? Remember, we're going to exponents here, so you're exactly right. Cube root is the same as the 1/3 power, and so that's where some people like do that all in one step. Their very first step is they write 1/3 log base 5, but when you're expanding logarithms, you want to have everything as simplified as possible, which means you shouldn't have any roots there, you shouldn't have any exponents, hopefully, if you can simplify them. We'll talk about the exception to that right now. Because when I have x squared plus 1, I can't break that up anymore, right? X squared plus 1, it's stuck together, so that has to stay like that. This one, I want to show you this just because if they make you go the other way, I want you to think about this. For here, most people are going to leave it like this, but what if you thought about factoring this? Can you factor x squared minus 1? That's the difference of 2 squares, x minus 1 times x plus 1. And I think in a minute I have one where it's going the other way that looks like this. If I remember correctly. And so now that you can break it up as factoring, now you have multiplication, and you can break up multiplication as addition. So you could break that up as, be careful with the subtractions on here, minus log 5 of x minus 1. Should I put a minus sign or a plus sign in between these two? I'm not sure. What did you say? If I have a plus sign here, because the rule is multiplication goes to addition, if you do that, you need to put parentheses around this whole thing because you're subtracting all of that. Does that make sense? Or you could distribute that negative sign and you could put minus minus because you're distributing the negative sign. So that one's kind of a tricky one. That's why I want to make sure that we did the other ones together too. Right, but it's one's a minus and one's a plus, right? Does that make sense? Yeah. Okay, but yes, If we're going to factor this into x minus 1 times x minus 1, then yeah, it would make much more sense to write it as x minus 1 squared and pull the 2 out front. Right? But because 1's a minus and 1's a plus, you have to separate it. So what I've seen before show up is questions that look like this. Right? So they would write it as log 5 of x squared plus 1 minus log 5 of x minus 1 minus log 5 of x plus 1. And people kind of freak out about the minus minus, but it just means they're both on the bottom, right? It just means that they're dividing by two things that are multiplied together. And so we'll see that again. I think there's maybe one on the worksheet tomorrow, and we'll end up talking about it. But just know that this is an okay answer if you don't want to distribute your negative. Okay? Okay, so the other thing you have to do is go the other way. What if they give it to you all separated and they ask you to put it back as one logarithm? And that's more useful in terms of solving equations. Because when we solve an equation, we usually just want one logarithm, not like 17 in the same problem. So, again, number 5 is kind of crazy. But number 4, use the properties that we have, right? So you should know what subtraction means to go back as division, addition means to go back as multiplication, and a number in front means an exponent for just that one log. So try number 4 and maybe see where you can get on number 5 before we go through them together. But at least number 4, can you put those numbers back together? And you're not done until you can just write it as log 3 of one thing. And the same thing here, you're not done until you just get only one log of whatever else goes with it, is what we're looking for. And feel free to talk to each other if it's more helpful. Or talk to me. So the 1/3 just stays, so like I never finished bringing this down. So all of that is just this part, right? So then this would still have to go, because I just didn't have it decided. There you go. So first up on this, let's do that too. Trying to put it back together. So like on this one, right, like we put this down. Right? So if something's in front, then it can go back up there. That's a great thing about that. Good writing too. What's wrong with this? What do you feel? Like maybe from here to here? Because you have to, when it says expand each logarithm, it means you can't have any division left in it, you can't have any multiplication, you can't have any powers. Because those are the three rules that we have to break up. So since this is multiplication, we break down those divisions. Alright? That was kind of tricky, right? Like that's one that on a test, if I gave it to you as x squared minus 1, I probably wouldn't have it. I'd do a bonus point if you got this, right? But the tricky part is, I wanted you to see this so you could do this. So I want you to see that you can have 3 logs, and that you can put it all back together as one. But that's why this is incorrect, because multiplication can always be broken up as division. This is kind of tricky. So, but what does subtraction mean? You at least do that part, right? What does subtraction mean to you? So you're going to divide by that. It's kind of ugly, but just do that. And then what does addition mean? Multiply. So that means you have to divide by this, multiply by this. And then the hard part is going to be after that, so multiply. But that's at least step one. As good as I can get it. I got that. It will. So the assignment is on the thing. Are you planning on going on a social tomorrow? Okay, so you'll be here maybe? Okay. I was worried about that. I asked if we should go check on you, but everyone else said no. No. But I was assuming you went to the nurse. I was hoping you were just like laying in the bathroom. Just like I go up and it's just like, well. I know, even though I didn't go there. Yeah, that's what I was thinking. It's so just for it. Why did you think back there? And then we're talking about this because I think I maybe disagree with. You put the 8 back up there, it's exponent, right? So that's not the 8th root of that. It's all that to the 8th power. And then we got to think about what it's like. So, yeah. It is weird. All right, let's check this first one really quick. Oh, that's what I wanted to say. So when I do these, especially when I first did them, you don't have to do it all in one step if you don't see it. When I see something in front, I always know that goes back as an exponent. Do that first if it helps you, and then you have to just know the properties. Subtraction goes back as division, addition goes back as multiplication of one log. So when I put this back as an exponent, that becomes log 3 of u squared minus log 3 of b. And once I have nothing in front, then I can say subtraction goes back as division, and you only write log once, right? So it's u squared divided by v, and you can always check if you broke it apart, would you get back what you had over there, and that's how you know if you did it correctly. Questions about that? What's wrong? What did you do? Oh, so you because you can't do 2 logs, right? Because it's just, it goes back as 1 log divided by that. That's what your property says back there. Okay, then I gave you a crazy one. Again, step 1. This number in front can go back as an exponent. So if I wrote that, that would be the square root of 3x minus 2 to the 8th power. And we'll talk about in a minute. What do I do to simplify that? What does subtraction mean I can do? Division. And again, we're not writing log more than once. So once I write log, it's just putting everything back together. So it's going to be messy, but I'm going to say dividing by 4 over x. And then addition again. What does addition mean? Multiplication of 4. If it would have said minus 4, then I would have divided by 4 down on the bottom again. But since it said adding 4, I'm going to multiply by 4. Again, I only wrote log one time. Now, it's not okay to leave our answer like this. We want to simplify this. I was down for like 3 seconds. I put the 8 up as exponent. Subtraction, dividing, adding, multiplying. I only wrote log once though. That's the big thing. How do you simplify the square root of something to the 8th power? Do you know what that was simplified to? So a square root is the same as a half power, right? So that's the same as 3x minus 2 to the 1/2 power, all to the 8th power. So what do I do with an exponent to an exponent? You multiply, so 1/2 times 8 is really to the 4th power. We don't really like fractions into fractions, so what's dividing by 4 over x as? The same as. What do I do when I divide by a fraction? Multiply by the reciprocal, so is that the same as saying times x over 4? And then I still have that times 4 out there. So kind of a lot of algebra coming back to you. It actually simplifies really nice because these 4's cancel out. So I think the best answer here would be, I'm going to put the x in front, x times 3x minus 2 to the 4th power. Now, there are not that many that are as ugly as those, like this one and number 3, I guess. But I just want you to be aware what's out there. And maybe, probably, on a test, I'm going to give you one that's like 3 logarithms and making you put together or separate them. But the rest of them are going to be pretty basic. What's wrong?
Why would you just break up the middle one into 2 subtraction ones instead of like automatically dividing by the first?
Because it said to put back as a single one, so for me, I just put it back together. If you break it up, so did you break it up and then just make it equal 0? So did you say log 2 of 4 minus log 2 of x? Is that what you did?
Not yet, but that's what I was going to do.
You could. I did it just because it said to put it back together, so when it said to put it back together, I didn't even think of breaking it up more. But it would make life a lot easier probably if I recognized this, because then what could happen?
Oh, the log 2 and the other one.
Minus log 2 of 4 plus log 2 of 4. But then what happens? That's a different answer than what I got, isn't it? I got x on the top, and that would give me x on the bottom. Is that true?
Is there a certain way you have to do it?
No, here's why. This really should be a plus sign, because of what we just did in the last one. If I'm subtracting all of this, that would be like minus this. So minus a negative would really be a positive, but I didn't distribute my negative, which is why I got a different answer. So you're right. You could have done it that way, but I screwed up when I did it that way, which is why I got a different answer. Because I would have done a plus log 2x. You see what she's saying there? I just didn't even think about it, because I just automatically put it back together. But definitely, if you see, well, hey, that would cancel out, it would make it easier, you could do it that way. Okay, I got one more rule for you that we did not discover on these posters, and it's an amazing rule because it lets you use your calculator to do any log instead of just log base 10 or ln, which is why when we have a test, you only get to use your calculator for certain questions. It is called the change of base formula, and it just says you can change any logarithm from one base to another. So I wrote the general formula there of if you have any log base a and you want to change it, that you can write it as log base b of the base goes on the bottom. The other number, I was trying to look what that number was called because we had that question yesterday. I found a couple things, and I'm just not confident yet that I trust the internet that it's the right answer. So I'm still working on what that number is called. But then that goes on the top. I think this is a silly formula to memorize because we want to change it to either ln or log base 10 because that's what we can do on our calculator. So these are the formulas that you need to make sure that you know. So if you want to change a logarithm like log base 5 to log base 10, all you have to do is draw a line straight. And I always remember the base goes on the bottom. They both start with b, right? So that means I could put log base 10 of a on the bottom and then log of x on the top. And I always write the base first because that's how I remember the formula. And then you can type that in your calculator, and we're going to do one in just a second on number 7. Some of you have fancy calculators that do other bases anyway, so you're not impressed by this. But for those of us that don't have fancy calculators that do other bases, this is really cool because it lets us approximate values that we weren't able to do before. Base E, remember that's ln. So if you want to change it, you get the same answer no matter which one you choose. But again, the base goes on the bottom. So you can say ln of a on the bottom, ln of x on the top. And what's really cool is that you get the same answer whether you change it to ln or you change it to log. They both approximate the same answer. So the only thing you have to do is make sure you pay attention to the directions, because if it says rewrite using common logs, then I want you to write it using common logs. If it says write using natural logs, I want you to use ln. But number 6, what is log base 5 of 89? Well, without this or a fancy calculator that does log base 5, we'd have to just approximate, right? 5 to the what power equals 89. We could just keep guessing. Or we can use the change of base formula that says this number goes on the top, so we can just take log of 89 divided by log of 5, the base is on the bottom. Use your parentheses wisely, right? On my calculators, it starts a parenthesis for log. You better close that parenthesis or you're going to get the wrong answer. And it says round to 3 decimal places. Biggest mistake that happens with this is people type in the calculator wrong, or they mix it up. They put 5 on the top and 89 on the bottom. I got 2.789. And if you think about it, 5 squared is 25, 5 to the third is 125, so that's a reasonable answer. And then this one I said use natural log to evaluate. Again, just practicing the formula. The base goes on the bottom, so this would be ln of 18 divided by ln of 5. And again, you can use your calculator. Close your parentheses. And you get 1.796. Because the formula says that ln, or any base, we could change it to. Like, we could change it to log base 12 if we wanted to, but our calculator doesn't do that. Does that make sense? If you did on your calculator, what's really cool, I think, if you take log of 18 over log of 5, it's the same thing as if you take ln of 18 over ln of 5. I don't know why it works. I don't know. I've always been like, oh, that's a cool thing. But it works. I don't know. On my list of things to figure out the answer to. This one, it has log base pi. That's a weird one, right? I guess gave you this one just to show that you can type it in your calculator, but ln of e is just 1, so you could just say that's 1 over ln of pi. That should give you the same answer. Use the pi button, not 3.14. I got 0.874. Did you get 0.874? So these problems on your homework aren't meant to be terrible. They're meant to just practice using the formula so that you can use it to solve problems later. But you will have to know this formula when we have a test. Questions about this? I don't think it's that bad of homework. We have some bad ones. There's no graphing today. That's nice. So here's your homework. 3 through 36, multiples of 3, 53, and 59 through 62. A lot of it is just changing. Like, condensing into one logarithm or breaking up, and they're not as bad as the ones that we did together. And then tomorrow I will record going over questions for the people that are here, and we'll have a worksheet. And so if you're not going to be here, I'll pass out the worksheet now, and then those that will be here, you'll just have some time to work. Probably there would have been a homework quiz tomorrow if so many people weren't going to be gone, which means good chance there could be a homework quiz on Monday, right?